Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, find all the zeros of the function h of x equals x to the fourth minus 6x cubed plus 4x squared plus 30x minus 45. So what are the steps to finding the zeros of a function that is x to the fourth power in a big polynomial? Here are our steps. Step number 1, find the possible rational zeros. So we're going to use the rational zero theorem to do that. Step number 2, use synthetic division until you get down to a quadratic or an x squared. And then 3, you're going to solve the condensed quadratic to get your last two zeros. All right, so let's start with step number 1. We're going to find our possible rational zeros, which are the factors of b, which is the constant here. So this here is going to be our b value, 45. And we always take the absolute value of it. That's why we don't care about the negative there. And a is our leading coefficient, which is in front of the variable that has the highest exponent. So in this case, the x to the fourth. So what is the coefficient in front of x to the fourth? Well, there's no number there, so there's a 1 there. All right, so then we are going to do our factors of 45 all over our factors of 1, which is nice because that's just 1. All right, let's write these out. So factors of 45, so there's going to be a lot of them. So we're going to have 1, 2 doesn't work, 3 works. 5 works. What's after 5? So I think 9 is the next one that goes into 45. Then 15 and 45, all over 1. Okay, so since it's over 1, it's pretty easy because you can just do all of these numbers here, each one over 1, which ends up being itself. So our possible rational zeros are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, 15, and 45. All right, so we're going to have to do a lot of synthetic division here in step 2 to hopefully get a couple that work. So really important, because this is an x to the fourth, we need to find 2 zeros that work out of this list, because our goal is to get down to a quadratic, an x squared. So if we find one that works, that'll just bring us down to an x cubed, or a cubic function. So we're gonna need to find 2 of these numbers that work. So let's go ahead and start with 1. So we put our coefficients of our polynomial right here, and always look out for holes when you're doing synthetic division. In this question, there are no holes. It goes 4, 3, 2, 1, and a constant, so we don't have to worry about holes in this one. And then negative 45, and I always draw a line to separate the remainder. All right, first step, bring down the 1, and we multiply. 1 times 1, which gives us 1. Add negative 5, multiply. Add, then we're multiplying negative 1 times 1, which is negative 1. Add, you get 29. 29 times 1 is 29. And will this be 0? No, it will not. So that's negative 16. So this does not work. So 1 is not a 0 of our function. So let's go ahead and get rid of our work there. And now we'll try negative 1. So 1, negative 6. So sometimes this can take a while to find one that works. So hopefully we'll bump into one that works soon. Okay, so next we bring down the 1. Multiply 1 times negative 1. Add, multiply, add, negative 1 times 11 is negative 11. Add, we get 19. And then 19 times negative 1 is negative 19, which is going to be negative 64. So that doesn't work either, because remember, if this is a 0, this number here, then you'd get a 0 as the remainder. All right, so negative 1 doesn't work. So let's try 3 is our next one. So we have 1, negative 6, 4, 30, and negative 45. All right, bring down our 1. multiply 1 times 3, which is 3. Add the negative 6 and 3, which gives you negative 3. Then we multiply 3 times negative 3. Then we add 4 minus 9, which gives us negative 5. Multiply negative 5 times 3. Negative 15. 30 minus 15 is 15. Then we multiply 15 times 3, which gives us 45. Uh-oh, we have a winner here. So we got a 0. So that's good news. That means 3 is a 0. Now I'm going to save us some time. I have tried all these other roots here, all these other zeros. None of them work. So that means and I've even tried negative 3. So what I'm going to do next is try 3, because we need to find another 0 that works, because this is a cubic function. This is your constant, your x squared, and x cubed. But we want to get down to an x squared. So I'm going to try 3 again in our cubic here, our condensed cubic. So we're going to use our new numbers so that hopefully we get down to a quadratic. So let's try 3. So bring down the 1. 1 times 3 is 3, you get 0. 0 times 3 is 0. Add the negative 5 and 0. And then multiply negative 5 times 3, which gives us negative 15. All right. So 3 worked again, which tells us that 3 is a double root. So 3 is a double root. So I'm going to write out our answers here. So 3, it just occurs twice. And then let's go back to our condensed quadratic here to find our last 2 answers. So remember, this is our constant. And then this guy here is our x, and this is x squared. So I'll write that here. This is our x, and then x squared. So we'll write out our formula here. This becomes x squared plus 0x minus 5 equals, we said equal to 0 and solve for x. So we add the 5 over, and then we take the square root of both sides. So we'll get x equals, and then whenever you take the square root, you have to put plus or minus, and then the square root of 5, which we can't do anything with. That's just the square root of 5. We cannot simplify that. So that gives us our remaining 2 answers. So we go back to our list of green here, of our list of zeros, and we just write down our last 2 zeros. Now you might be asking yourself, well, there's only 3 answers here. There's 3 and then plus or minus 5, but we have an x to the 4th. There should be 4 zeros. Well, you are right. There should be 4 zeros, but remember 3 is a double root, so 3 actually occurs twice. So there are 4 zeros, but 3 happen to occur twice, but we don't need to write it twice. Once is plenty. All right, so here's our list of zeros for this question. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.